Hello, this is Mr. D. Simone, and I'd like to welcome you to Module 3, which is on three-dimensional polyhedra. In this module, you will learn how to describe and explain what two-dimensional cross-sections of a three-dimensional object look like, the type of object that is generated when you rotate a two-dimensional object about an axis, and describe, explain, and analyze how to create a net drawing of a three-dimensional figure. Okay, so cross-sections. Three-dimensional objects have parallel, perpendicular, and diagonal two-dimensional cross-sections. Okay, so a cylinder has a parallel cross-section of a circle, a perpendicular cross-section of a rectangle, and a diagonal cross-section of an ellipse. And you can see by this chart, and we do have a similar chart on the webpage you can look at, you can see the different cross-sections of cylinders, cones, spheres, and square pyramids. Okay, net drawings. Net drawings show how two-dimensional objects are used to create three-dimensional objects. So, for example, a cylinder is made up of two cylinders and a rectangle. A cone is made up of a small circle and a larger quarter circle. A sphere is made up of a series of elongated pointed ellipses. And a square pyramid is made up of four equally sized triangles and a square. So if we rotate two-dimensional objects around an axis or around an object, they will create three-dimensional shapes. So we could do this with any of our circular three-dimensional objects. So a cylinder can be created when I rotate a rectangle about an axis. A cone can be created when I rotate a right triangle about an axis. And a sphere can be created when I rotate a semicircle about an axis. Okay, let's talk about the surface area of a cylinder. Okay, to find the surface area of a cylinder, we're going to find the area of the top and bottom bases. Okay, so the area of the top and bottom base, they're circles, which the area of a circle is pi r squared. And then we need to find the lateral surface area. Okay, and that lateral surface area is going to be 2 times pi times the radius times the height. So it's basically the circumference times the height. So when we add that together, we'll have 2 pi times the radius squared plus 2 pi times the radius times the height. Okay, the surface area of a cone is similar, except in this case we have the circular base, and then we have that we don't have a circle at the top. It goes to the top is a vertex. So in this case, basically we need to find the area of the circle, okay, pi r squared, plus we are going to find the area of the conic shape on the top, which is going to be pi times the radius times the slant height. Okay, to find the surface area of a sphere, it's just basically going to be 4 times pi times the radius squared. So the surface area squared is very easy to find. It's just basically the radius squared times 4 times pi. Okay, pyramids. We haven't talked about pyramids yet. The volume of a pyramid is 1/3 the product of the area of the base times the height of the pyramid. So if we're mostly working with square pyramids, so the area of the base, a square is going to be side times side, and then we're going to multiply it by the height of the pyramid, and multiply that by 1/3. Okay, the surface area of a pyramid is just the area of the base plus 1/2 the perimeter of the pyramid times the slant height. Okay. So in a square pyramid, that would be, the base would be, again, side by side. And then the slant height is going to be the height of the triangles that are making up the sides of the pyramid. Okay, so go through the lesson. There are some good charts, and read through all the web pages. And at the end, you can do the homework assignment and the activity and contact me if you have any questions.